Europa, one of Jupiter's moons that is not in the Goldilocks zone, remains warm. Jupiter and the moons that circle around it are really sending energy to Europa. Stargazers have been keen on Europa, Jupiter's intriguing moon, for an extremely significant time frame. From the time it was seen in 1610 until the explorer trips in the late 1970s, there were hints that there may be a sea underneath the ice. It required many years of examination and study for the James Webb Space Telescope to make its astonishing 10-hour perspective on Europa. What secret things did this long review show? Might it show that there may be life beyond Earth? What kind of sign is this? Watch as we investigate how the Webb Space Telescope checked out Europa for 10 hours and then saw what may be an indication of life. Europa is one of more than 90 moons that Jupiter has. It is the sixth moon that is closest to Earth. Io, Ganymede, and Callisto, Jupiter's other three biggest moons, were the first moons observed outside of Earth's orbit. The Galilean moons were discovered in January 1610 by an Italian researcher named Galileo Galilei, using a telescope that he made himself. The surface of Europa is for the most part comprised of silicate rocks, and it likely has an iron-nickel core inside the water ice. The air around it is really thin and mostly comprised of oxygen. There are dull, rosy-brown cracks all around Europa's ice surface. The moon's surface doesn't appear to be more than 40 to 90 million years old, based on the few craters that have been seen. This is extremely young in geological terms. Beneath Europa's frosty surface is an expanse of salt water about 2 times as large as the sea that covers Earth. So, they felt that Europa may be one of the most promising places in our solar system to search for life other than Earth. Researchers believe that the salt water beneath its frozen shell holds twice as much water as the world sees and may indeed contain the chemical building blocks for life. A potential scenario from many years ago was popularized in science fiction. Consider the possibility that life from other planets could have flourished in a sea beneath Europa's frozen surface. Europa went from being unknown to being the center of attention because of this thought, and it has remained there. People inside and beyond science are getting more and more excited about finding life beyond Earth using this data. That fantasy, on the other hand, may be rooted in truth. Spectroscopic studies done with a telescope at the Kitt Peak National Observatory in Tucson, Arizona in 1972 showed that the majority of Europa's surface is comprised of water ice. Warm models from 1971 also showed that Europa may have a layer of liquid water at its core. In the early 1970s, the Pioneer 10 and 11 spacecraft flew by Jupiter, but it was the Voyager 1 and 2 spacecraft that took the first high-definition pictures of Jupiter's moons from a distance of about 1.2 to 2 million kilometers. Voyager 1 came extremely close to Jupiter on March 4, 1979. The spacecraft snapped a photo of Europa, and a couple of months later, on July 9, 1979, Voyager 2 flew by Europa. Extremely close pictures from the two Voyager probes showed a surface that was brighter than the moon's and had numerous ridges and cracks across it. There were no large impact craters, high cliffs, or mountains on it. We could also say that Europa has an exceptionally smooth surface compared to the other icy moons. Voyager pictures showed just a few dark scars. These are believed to form over time as meteors hit the surface of a planet repeatedly for billions of years until the surface is full of craters. Since there were no large impact craters, it was imagined that the moon's surface was relatively young and that the craters had been removed by something like ice volcanoes or the frozen crust settling under its own weight. These astonishing finds made people even more excited for NASA's Galileo mission, which launched in 1989 and arrived in orbit around Jupiter in 1995. Galileo's main job was to fly by all 4 Galilean moons multiple times. Because the data Galileo sent back about Europa was so interesting, the mission was extended for a second journey, lasting 2 more years and known as the Galileo Europa mission. The spacecraft flew extremely close to the icy moon multiple times. Galileo's most significant finding showed that Jupiter's magnetic field had reversed near Europa. This clearly indicated that a thick layer of electrically conductive liquid beneath Europa's surface is creating a specific type of magnetic field. Researchers imagine that the most likely thing that could be causing this magnetic signal is a massive expanse of salty water beneath the ice. Europa's ice shell is 10 to 15 miles, 15 to 25 kilometers, thick and floats in water 40 to 100 miles, 60 to 150 kilometers, deep. Despite Europa being only a quarter the size of Earth, its ocean may contain 2 times as much water as Earth's oceans. The water around Europa is one of the best places in the local planetary system to search for life beyond Earth. During Galileo's visit to Jupiter in the 1990s, no plumes were seen. However, newer observations from telescopes like the Hubble Space Telescope and a reanalysis of some Galileo data have shown that Europa may have thin plumes of water that are ejected 100 miles, 160 kilometers, above its surface. In November 2019, a group of scientists from around the world, led by NASA, announced that they had found water vapor directly above Europa's surface. Interestingly, a spectrograph at Hawaii's Keck Observatory detected the vapor by examining the chemicals in the atmospheres of distant planets by measuring the infrared light those atmospheres emit or absorb. If the plumes are real and come from Europa's ocean, a spacecraft could fly through them to collect samples and study them from space, which would be similar to researching the Moon's ocean. This was done by NASA's Cassini spacecraft on Enceladus, Saturn's moon, which is believed to have an ocean that shoots out into space. To continue exploring, the James Webb Space Telescope used 2 main instruments to observe Europa, NRCam and NIRIS. The near-infrared camera, NRCam, which is James Webb's main camera, is NASA's replacement for Hubble and Spitzer. Its main job is to take very clear pictures in the near-infrared spectrum of light. NRCam has 2 parts, one for wide-field pictures and the other for coronagraphy, a method of blocking out the bright light that stars and planets emit, allowing dimmer objects in the background to be revealed. NRCam gathers light from the first stars and galaxies, as well as stars in nearby galaxies, young stars in the Milky Way, and objects in the outer solar system. The Kuiper belt's frequency range is from 0.6 to 5 microns. Space experts can utilize NCAM coronagraphs to take pictures of things that are extremely faint and near a focal light source, like star frameworks. Coronagraphs on NCAM work by hindering the radiance of a brighter object so you can focus on a nearby object that is less bright. This is similar to how raising your hand over your eyes in the sun lets you focus on what's in front of you. Cosmologists intend to use coronagraphs to learn about the properties of planets that orbit stars nearby. The close-infrared spectrograph, NPC, on the other hand, tests groups somewhere in the range of 0.6 and 5 microns. A spectrograph, which is also called a spectrometer, is a machine that diverts light from an object into a spectrum. The spectrum of an object can tell you about its temperature, mass, and chemical composition, among other things. The object's particles and atoms leave marks on its spectrum that are unique to each chemical element, and this can tell you a lot about its physical state. Spectroscopy and spectrometry are 2 of the best ways to study the world since they can be used to figure out what these lines mean. Webb looks at a lot of extremely faint things, like the first worlds that formed after the Big Bang. It takes many hours for Webb's enormous screen to accumulate enough light to make a spectrum. During its 5-year mission, the NRCam will see 100 objects at the same time, which will allow it to observe thousands of worlds. NRSpec is the first space-based spectrograph that can see more than one object at once. As for how close Europa's sea is to its surface, Dr. Gono Villanueva stated, "I believe that question has been a significant inspiration for Europa investigation. This suggests that we might be able to learn some essential things about the sea's structure even before we drill through the ice to get the full picture." Dr. Gono Villanueva is a planetary researcher at NASA's Goddard Space Flight Center. He studies life in space and searches for it on Mars, Venus, sea worlds like Europa and Enceladus, as well as on primitive bodies like comets and distant exoplanets. He is the Associate Director for Strategic Science in the Solar System Exploration Division. Additionally, Miscreant Waa is the lead researcher for the Comet Interceptor's MAYUS instrument, a co-investigator for the ExoMars TGO mission, and the James Webb Space Telescope pioneer for studying Mars and sea worlds. Space experts have already used the Hubble Space Telescope to get early reports of plumes coming from Europa's surface. Early on, experts used NRCam to check Europa out while blocking the light from Jupiter. This was seen on January 9, 2023, when Europa was around 10 hours away from Earth's nearest point. James Webb's main screen, which is 6.5 meters tall, was aligned correctly with Europa during this time. NRChem and NRSpec both gathered data simultaneously. The specialists say that Webb found no plumes while it was observing Europa, but that doesn't necessarily mean there aren't any. Heidi Hamel said, "There is always the possibility that these plumes are variable and only visible at certain times. All we can say confidently is that when we requested these observations with Webb, we didn't detect a plume at Europa." Hamel is an interdisciplinary researcher who works on the James Webb Telescope project. She focuses on Webb's subjects of planetary systems and how life began. She has used the Gemini, Hubble, Keck, Spitzer, and other telescopes to study the outer planets of our solar system, as well as their rings and moons. As a planetary scientist, Hamel knows a lot about how to use Hubble to examine the solar system. She was responsible for the Hubble team that investigated what happened when comet Shoemaker-Levy 9 collided with Jupiter in July 1994, focusing on how Jupiter's atmosphere changed. Here is a deeper look at what the James Webb Space Telescope found on the surface of Europa. On Europa's frozen surface, researchers found both crystalline and amorphous carbon dioxide. Amorphous means that the structure of the molecules is not organized, unlike crystals, which have a regular pattern. Carbon dioxide is one of the most important gases on Earth. It is composed of one carbon atom and two oxygen atoms. It is thought to be vital for life because it plays a role in breathing, metabolism, and photosynthesis. Additionally, it's a greenhouse gas that traps heat and affects Earth's temperature. The researchers were first interested in where the carbon dioxide came from. Did it come from beyond Europa, or from other places, like micrometeoroids or other things from outside the moon? It was about the same everywhere, but in this case, it was only in one location. Geologists believe that this area is a newly disturbed region, which is very interesting because it suggests that something is happening below the surface. The current question is how carbon dioxide got to Europa's surface and why it's only found in one place. It's likely that some of the carbon came from Europa's underground sea, which is believed to be a potential habitat for life. The sea is thought to be about 100 kilometers deep and contains more water than Earth's oceans combined. The water stays liquid due to the tides caused by Jupiter's gravity, which stretches and compresses the moon, warming the interior and keeping the water fluid in some areas. There is ice 10 to 30 kilometers thick between the sea and the surface. This ice is not just sitting there, it's dynamic, cracking, venting, and impacting, which allows material to move between the sea and the surface. Dioxide that was found might have come from various places, like substances, or, on the other hand, natural cycles occurring in the sea and being conveyed by flows or jets. It could likewise have been dissolved in seawater and released as gas or ice when the temperature or pressure changed. This spot on Europa, near its equator, is where carbon dioxide was found. It covers around 12% of the planet's surface area. These breaks in the ice let things move to and fro between the sea and the top. There are multiple ways that the carbon dioxide that James Webb found might have gotten to the top. It might have been broken up by seawater and then returned as a gas or ice when the temperature or pressure transformed. It might have also been made in the sea by chemical or natural cycles and then brought to the top by flows or jets in the sea. The carbon dioxide was found near Europa's equator. This region is called disorder landscape because it has a lot of different types of landscape, for example, edges, cracks, blocks, pits, arches, and impressions. Many people believe that the ice's confused appearance comes from the way it interacts with the water beneath, which makes it soften, freeze, separate, and refold itself. This region is also one of the most occupied and diverse topographically, which makes it an extraordinary objective for Webb sensors. So, what does this find have to do with whether Europa's sea is livable? There might be organic particles or living things in Europa's water. Since there is carbon dioxide on its surface, organic molecules are particles that have carbon in them. They are important for life as far as we might be concerned. Organic activity is any process that involves living things or things made by living things. The significant thing about this finding is that it has to do with both organic particles and organic activity. When carbon dioxide and water mix, carbonic acid is made. This acid can then break down into bicarbonate and hydrogen particles. The pH, acidity, temperature, and flow of the sea might change because of these particles. This could also change the chemical compounds in the environment in ways that could help different types of life. These chemical compounds can combine with other elements or molecules to make more complex organic compounds, such as sugars, amino acids, nucleotides, and lipids. These are the molecules that make up carbohydrates, proteins, nucleic acids, and lipids, which are the building blocks of life. They can also hold information or energy that living cells could require. Carbon dioxide may also be taken in or made by living things in the ocean. It might be used as a source of carbon and energy by certain microorganisms through photosynthesis or, alternatively, chemosynthesis. Carbon dioxide was found on the surface of Europa, which could assist us in learning about the sea's composition and how it moves. We can consider how much carbon is in Europa's sea, how it switches forms and goes up, and how it combines with other molecules or elements. We can also figure out how it affects or shows other biological or physical processes by checking the sum, area, atomic composition, and changes in time of the carbon dioxide on its surface. It could also help plan future trips to Europa. One of these projects is NASA's Europa Clipper mission, which will fly by Europa numerous times to learn about its stones, atmosphere, and climate. Plasma screens, cameras, spectrometers, radars, and spectrometers will all be on the Europa Clipper. It will also send a lander to the surface of Europa to study and gather objective data. It will use information from James Webb to pick the best locations and methods for its research. It will also test the possibility that Europa's sea is habitable and search for signs of life. Researchers and people who like space are excited about two missions that are going to Europa. The Clipper mission, which NASA intends to send in 2024, gives us hope that we can learn more about this strange moon. Its goal is not only to investigate but also to carefully observe Europa from orbit. This endeavor is an important step towards solving the mysteries of this very distant world. In its orbital sweeps of the moon, it will focus on finding chemicals and conditions that are suitable for life. Similarly, the Jupiter Icy Moons Explore (JWST) mission from the European Space Agency, which was launched into space in April 2023, shows a lot of promise as it draws nearer to Jupiter and is set to arrive there in 2031. It will begin a long journey that will include 35 flybys. Europa, Ganymede, and Callisto, two more intriguing Jupiter moons, will be involved in these carefully planned encounters. This sweeping arrangement for research paves the way for a full report of the entire system of Jupiter. It gives us a better way to look at the wonders of these frozen moons and may meaningfully change the way we think about how life could exist beyond Earth. Thanks for watching. Click the film on your screen to see more videos like this one that will take your breath away.